Hello and welcome back to Made Up of Wires, where we're decompiling Castlevania Symphony of the Night. You can go to soten.z.dev to learn more about the project. I'm was getting a little I don't know what, the melancholy about the progress that's been made, and then I looked at what has happened in the last week. We'll talk a little bit about that, and my spirits are up. I feel like, in general, decompiling has been going a little slower. However, the work that's been done is kind of twice the work that used to be done. We used to largely work on the PSP and US versions of the game, or any version of the game, just as independent pieces, and it required some duplicated effort, because when you got to another version of the game, you would have to see how the code looked and try to get it to fit another compiler, another system, another API. But when we do them at the same time, we kind of get the benefits of both worlds, and it takes a little longer. But as a whole, for getting all the versions done, I feel like in general we move faster. So I think I'm happy with where things are at the moment. I'm just a contributor on this project. We've been working on NZ1. A little surprised that this didn't go up a little bit more. All the work that we've been doing lately on the stream has been checked in. I guess we went from here to here in the last week. We're at, it looks like 83-ish% of the way done. There's been some new contributors that are looking to duplicate a bunch of that code, so I don't think I'm going to work on Clock Tower anymore, or at least not for a little while, until that gets worked out, and let other people kind of learn about the project and learn how to contribute to that. So we're going to start something new, and I'm a little bit excited about it. So the other thing I promised to do, and I probably forgot to do last Monday, but now I'm going to do on Mondays, I was going to give a quick recap of what's been going on in the project, and some really cool things, like I said, that have gotten me excited, have been done in this last week, that have been a long time in coming. And so I'll talk about a few of them specifically. So if you've watched the stream before, you'll notice that when I'm building the project, I type make build all, and the reason was because the build all target was made to build all versions of the game, but it wasn't being tested through CI, so I didn't feel comfortable making it the default target. I had CI scripts, but I can't test them because I'm not an owner of the repository. And so I'd done some stuff in my own fork, but caching and other things that I couldn't necessarily test. GitHub Actions I find odd to test in a reasonable way before submitting to PR. Anyway, I got most of that worked out, and I'll have to look at some of the other related commits. But it seemed like many of the other developers were using build all as well, and so I finally pulled the trigger and submitted a change to make that the default target, and that landed along with some additional work. There was some breakage, it looks like, with the Saturn build of the game. I don't build the Saturn version of the game, and it doesn't go through our normal build process, and that actually might be something to look into. We have kind of a portable test build as well to make sure the code is portable that we're decompiling, and that we have everything necessary when one day somebody might want to compile for a foreign system that we're not decompiling. That's not mixed in with this either. But a lot went into making this possible. So the biggest thing was moving away from Make and moving to Ninja. Zianimo, who is the project leader, he did this last year, and I was actually opposed to it. I hadn't used Ninja, but I didn't like the idea of a generated build graph. I shouldn't say I didn't like I definitely like the idea of generated build graphs, but I want that to be declarative. And the way that Ninja works is mostly people writing imperative scripts to generate their build graph, and then running Ninja to execute that build graph. Still not my favorite paradigm. For things that can be static, I much prefer them to be statically configurable, not dynamically configurable. But the first thing it allowed us to do was combine the build graphs between the PSP HD, and HD is debug hard disk build, not something that is relevant to most people, and US versions of the game. Is JP in there? Oh no, JP's not in there because we're not building the JP version. There's some things I want to get to in the JP version, but haven't gotten there yet. So those 3 versions of the game, combining the Ninja build graph for all of those, and all the work Cynamo did made that relatively simple. The big thing was assets that conflicted. So most of the assets in the game, images, sounds, icons, things like that, they're identical through all the versions of the game. And so I had done some work with the assets tool to make sure that when those were being written, they were being written atomically. So it didn't matter which versions of the game wrote that asset. Just that when the build system saw it, that it was a consistent view of that build. And then for the assets that were different, that we just namespace those to the correct version of the game and some infrastructure around that. And that all worked well. And so then we could build all the versions of the game. And I've been doing that for several months. And we finally, now that's the default build target to make. So anyway, super happy about that. A lot of work done by a lot of people to make that possible. When I when I was doing the namespacing for Soten assets, Cynamo kind of questioned why I was doing it and said eventually he wants to get to this state where he can build all the versions of the game at the same time. And he didn't know that that's exactly why I was doing that work, and that I had a parallel build for all the versions at the same time. So I'm glad everything got through and worked out. All right, so that was a big one. Why am I looking at the build for this? I don't want to look at the build. Oh, that was something unrelated to the news. I don't want this one either. I wanted this one. So Cinemax diligently adding and fixing the enums that we have for sound effects and other assets. Always nice to see updates there. This is another huge one. So I've complained about Python in the past, and I will continue to complain about Python probably forever. But in general, Python is slow, and Splat is written in Python, and for the most part, all the Splat extensions are also written in Python, and we were using those throughout. And one of the things that Cynamo built probably close to a year ago now was the Soten Assets tool, which replaced a lot of those Splat extensions with a single binary that would go and handle all of the binary assets. But we still have a few things that are not done that way, and so basically going through and cleaning up, getting the CMP graphics and palettes out of that Python code path and into something a little faster, and then actually getting rid of those extensions altogether. And it looks like there's 2 left. Raw, I would imagine, should be relatively straightforward. I'm not familiar with the anim sets at all, but that might be worth looking into. NZ0 for PSP was brought in, and a bunch of work was done to deduplicate a bunch of that as well. So now we have another PSP overlay. Most of the existing overlays should map. I should fix, I talked about it a few months ago. I did some work to get the weapons started for the PSP. The layout of those is very different. On the PlayStation, there's 2 weapon files, one for left hand and one for right hand. And the game knows the offset in that file to load. for each weapon as they're being brought in. For the PSP, each weapon is in a different file. And so I came up with a scheme to be able to build those from the same source code while still maintaining the difference. And I need to go back and get that going. And I think along the way, so for PSP, I was able to get left and right hand files building. We don't have whatever the true hand is. We have the false hand, but not the true hand. I don't know which one is which offhand. Pun not intended, but I wish it was. Anyway, so we have another NZ0. And then Gamester was doing a bunch of work naming symbols. This is like super important, and I think oft overlooked. It's fun to, for me anyway, it's fun to go through and decompile things. And I think that's kind of the glamorous part. What's less fun is going through and trying to find out what the purpose of some of these functions are that we don't have named yet and give them names. Even less fun going through and naming the data. So always good to see people going through and making that a priority. So I said that I think we're going to start something new, and I meant it. So I was going through and looking at where to look. I thought it might be interesting to see what is left in main. I'm guessing it's a SDK function, but I'm not quite sure. And my guess is that it's something non-trivial. We could look at it before moving on. But then I was looking at what else. Any of the stages in the reverse castle are fine, and if people want to work on that, I could do RNZ1, which would be the reverse clock tower, which should be have a lot of overlap with what we've just been doing. But then I was going through and looking at the bosses, and the bosses are largely untouched still. And then I saw RBOO and thought, Rolf Grant and Sifa, I think that's the one. So I think we're going to work a little bit on RBOO and try to get that going as well. And depending on how that goes, we could either abandon it or move on to NZ1. But we'll do the PSP and the PlayStation versions at the same time. We'll go through importing those and getting them to build in the build system, and then pulling out code. And I'm going to try to use Project Oblivion's tools, if I can remember how to do that, and we'll go from there. So first I'm going to look at this, see what's in main. The file on the disk is slus000.67, which is the serial number, or like game ID for I need an R there. There we go. So we have a sequential read, which almost seems like a DMA type function. And then C00011, which is a DMA function. I wonder if they're related in any way. DMA execute and cont data entry. Let's look at DMA execute. So I would expect this to have custom assembly, and so we might have to leave some assembly in there. So this is going to be telling either a coprocessor or something else that it wants memory from one memory map device to another. That's my guess anyway. And so when I think about how functions like that work, so DMA to me is usually like hard disks to RAM or like connected devices. So you might say like FireWire, for example, supports this. Hey, FireWire device, take these blocks of data that you have, by reference, write them to RAM at this address, and then hardware takes care of all that, and you don't have to worry about doing it on the CPU. So I'm expecting something similar to that. But you might have to tell some device how to do that, and that might include talking to registers or virtual addresses that may not be otherwise used. This is valuable because it's part of the PlayStation SDK, and it looks like most of the SDK functions are now decompiled, which is cool too. Let's first look at it and see if there's anything funny going on. So this was in libcd, so I'd expect this, like I said, to go from pull from the CD into RAM. And I'm sure somebody else has started this, and we can look at what has tripped them up. I still will probably start fresh. There's a few things in here that we might be able to figure out from the SDK itself. Possibly values in memory that are unnamed that could be named. And we could look at that. So let's see if some of these have names yet. And the best way, I'm going to keep Gamesters open. See if I pass the test this time. I did, I think. So I want to see if any of these have names yet. They don't. Let's do this. I mentioned that I built a bunch of tools for navigating SDK library things. So let's use those tools. So the PsyK tools are a partial recreation of the scilib and dumpobj tools that came with the PsyQ SDK. These were available for a bunch of different systems, and so I went through and found the binary formats or reverse engineered them and came out with similar tools. So let's see if this is going to find this in the workspace. Right, there we go. So we're going to be looking in libcd, and what I want to do is do a recursive listing with decompilation. I'm going to use list. I'm going to use, let's do help there. Disassemble recursive. And in the test directory, I have a git module. Why is this not filling in? Oh, because maybe. So we have PsyQ, we want 3.5. Why is this not auto-completing? I would expect an autocomplete. I think it's 3.5 libcd.lib. We'll try that. Oh. Let's hit submodule init update. Now maybe this will work. So 3.5 is what the PSX. 3.5 is what the Symphony of the Night was compiled against. So we'll look at that version. This should be relatively similar. So what I want to see is some of these offsets. Do we have enough information to determine what those symbol names were? And maybe we can extract some of the symbols from there. Hey, Cristiano. Hey, Dizik. Good to have you both. So what we should see is a, and actually maybe not, I was going to say we should see a DMA execute function. Oh, there is a DMA execute function, and it's going to be part of, this should be libc01, or is lib, what was it? C_011. That was it. No, I'm wrong. C_011. Yeah, the symbol should be in there somewhere, but it's not. How did this name come to be? Oh, because it's going to be capital, because this was DOS. There we go. And actually, that's not the only object there, but it is the object that we're interested in. So we, what we could do is extract just this. I should add like a filter to the list command to be able to only choose the objects in the library that you want. But that's not how I have it. So one interesting thing here is that we get the original file name. So we're calling this C_011. The original file name was actually cd-rom.c. And let's actually look at the other file names here and see. They all came from cd-rom.c. No, that's not true. The cd-rom object did. So no, not all of them did, but I wonder why C_011, why that ended up in a separate object from the others, but coming from the same file. Not sure, but so DMA execute is a linked function, but it's not a exported function, so we don't see it in the export list. And here's where it tells us that, one, it's a local symbol, not global, so we're not exporting it. And it's at offset 9A4, so we could go back up to the code listing and look for 9A4 and find it. What I'm really interested in is some of the symbols there. So let's go to 9A4. And we don't have a listing like that, do we? We would have 9A0. I don't. We're not getting that offsets. Bummer. We're not getting those offsets. Yeah. So what I was hoping to do was, and I haven't done this yet with the Psyk tools, is start implementing these patches. So the way that relocations work in Psyk is you get sections with different symbol names, and so at link time you'd resolve DMA execute, for example, which says it's at offset 9A4 of this object. And so everybody who's calling DMA execute, you'd take the virtual address where this particular object is going to be written. You'd add 9A4 to it. and then you'd find that things that reference DMA execute and fill in the appropriate offset. What's odd is we do get the local symbol, but other things are not referring to it as DMA execute. Otherwise, I'm doing a search for it, and this is the only time it comes up. So that is somewhat interesting. The other thing that is, I think, interesting is we have all of the data here, and maybe not all the data, but we have a significant number of names for the things in data. And so we could go look at the data surrounding libcd, especially here. And all of this data originally came from this library. So we see scratch space again here, which is kind of interesting. But like this here. And I'm assuming that libcd is mapped. I don't know for sure. And maybe even C11. But this particular symbol is not. Yeah, and so this is, right now, this is just anonymous. So this is data that we could probably map, and we should have the symbols for it. Probably starting at the beginning there. So these are all addresses into the scratch pad. No, maybe not. This is after the scratch pad. So these are, yeah, probably device mapped addresses. And it might be interesting to look at what those are. Going back to those listings, so we have the ones that are in SPSS. Across def is an exported function. Something called header area.2. Cross references to symbols that are not in this library. Mem to mem, it's in section 2, so I believe that's a function as well. I would have expected, and maybe not, because these, so it looks like the other non-BSS symbol names are stripped. So unfortunately, I don't know if we're going to get anything valuable. Yeah, so in the code listing, the way that I currently have it set up, it uses Rabbitizer to generate the code listing if it is MIPS code, and when it does that, it doesn't give you an offset. So I should fix that in. Maybe that would be a nice improvement. So what I want to see is, do we have, oh, this actually looks a lot like the data that we were looking at. So this is, again, Little Indian 32-bit 1F801800. Not quite that, but pretty close. So let's look at that. 1F80 1800. So it does get associated with C underscore 00 or 011. And I'm going to look at, that is right where it starts. Let's look at the splat config. This isn't what I wanted to spend my time on today, but now I'm intrigued. So this is part of RO data. So these would be marked as consts probably. But then we're referencing data in this 23678 file as well. 23678. I think that this should be probably part of C underscore 011 as well. It's data. So let's go back and look at that and see if we could tell where that is in here. So we need a 1018, and the way that sorry, confuse myself as to which direction. So it'll show up as 1810. 18 space 10. Is that right? Yeah, that's right. And so we do see it possibly right after that, 16 bytes later. Are we just not including it? How long is this? Yeah, this is only 16 bytes. So all this following data is part of, well, maybe not all of it, but a bunch of it is part of C011 as well. And we know that from the library. That goes until 7410, so let's look at that. It'll be 1074 in. So really, yeah, this should be going at least to 236B0. Let's look one more time. There's just padding after that. But there was actually another section down below. And with that, there was some data there as well. So 4D44 we could look for. That actually is the RO data string, I think. Yeah. That is exactly what it was. And so that's mapped already. So these zeros, actually, the extra zero padding, at least one set of zeros was there, and we could see if the other ones were. Too far. So we have 2 words worth of zeros. Following it. So 2, 3, 6, B8 is actually where C11 ends. So I'm gonna duplicate this, add a new one, add OX. Yeah, good. Paste properly. Try again. And I'll leave this as a regular data. Not a dot data, because that data hasn't been imported yet, but it should be part of C011. But that doesn't tell us what those symbols are yet, just that they are there. And let's build and just make sure that I didn't screw anything up. And unfortunately, I don't think that any symbols are going to come from that, which is a bummer. But we can work on this. This uses the scratchpad a bunch, and I just pulled scratchpad stuff out into a different header file. Oops. This is what I want. So we'll get those updated. Scratchpad and spad. Macros, they're mostly the same, just slightly different. And so we need to think about this being written not necessarily by written for memory addresses that we don't necessarily have direct access to normally. I'm going to do a quick search for this address and see what I can find about it. Besides the scratchpad, I'm not terribly familiar with a lot of the other mapping. It's like 88. So it looks like these actually might come from a header file. And we can search those as well and see if those are available to us. It's like a macro called DMA CHCR. So this is not showing up. A little surprised about that. Interesting. So we actually have some macros. I should fix this. There are macros from the original SDK for the scratchpad. And why wouldn't there be? Okay, I'm going to do one more search just for anything with the 1F80 prefix. See if that shows up anywhere else. It does not. I'm surprised SDK docs don't come back. But worth noting. So this does show up in lib.etc. And let's look at that again. These are interesting too. Probably worth importing. Okay, I will consider that later. So let's get back to this. What I found was there's a repo called psxdev, which looks like maybe an ARM port of the PlayStation libraries, and so they provide a bunch of macros. As far as I know, these macros don't exist in the original PlayStation SDK. Give me 1 second to do one more search. A lot of this is exploratory. So, what is the license? If this has a nice license, maybe we will leverage that. MIT license, so that is more liberal than what we have. Ours is a GPL 3, so that should be fine. So I think I'll use these macros. We need to make sure that we are giving credit as appropriate. So let's oh, these are nice. They're typed as well. Not necessarily the same types that we would use. So we'll have to adapt this a little bit. So we're casting the value as a pointer to that type and dereferencing it. That seems fine. So let's take these DMA macros, take them all. And we'll have to define our own IO32. And we'll dereference, what is it? Is it unsigned or signed? Yes, unsigned. Oh, that's interesting. I believe C preprocessor comments are the same as C comments. But I don't know. That's a good question, Roaming. We'll have to see as we get there. So we have these set up, and so when we see things like offset 10BBB or 1088 B's and 8s, my eyes are getting too bad to tell the difference. We can kind of leverage this DMA char, whatever that acronym is. And it looks like temp A1 is already being multiplied by 10, so that fits with what we know. So we should be able to just use arg0 there. And let's do a search for all of those, and we'll try to get them all at once. So this looks like it's polling this address. That's my guess right now. For some flag. Yes, I have seen it. So I have it open here. This is GameStar 81. It's from 4 months ago. And so I was gonna start over. And I don't know that mine is right versus what Gamester81 did. So he assumed that this offset was a DMA control struct. We'll see if that works out one way or another. A lot of times when there's functions like this where they're stuck and nobody's made progress on them for a while, I don't mind going back and just starting over. Okay, so that's the first one. It looks like our E84 is going to be a something probably with signed 16s. Let's do unsigned 16s because there's bitwise values there. So I'm just going to make this a unsigned 16 array. We could go look at that and see what it is. Interesting. So, yes. And so possibly what's happening is that this is just a value that's in the A2 register. So Dizik is saying, printf, there's only one arg to the format statement. And so this other one probably isn't an arg. When I get this compiling, we'll take a look at that. I'll make a note. Thank you. This loop probably needs to be excised. I want to get the other structs, or whatever these are, compiling. And then once it's compiling, I can look at that a little more. So this is interesting. This is kind of a backwards pointer. So our offset here is 1080. 1080 is this macro. Again, arg0. So I think that this is offset 4 here. Not sure. Well, again, we'll see as these work themselves out. It is +4 and then another 4, so it might be this DMA CHCR function. We'll see. %. Not very good. All right, so let's do some cleanup. Let's look at the printf and see what's going on. Where is our load upper immediate 1 coming from? It's such a mess, I can't even tell. Deleting that gave us 11% improvement on the match. I'll take it. These all look like they are and equals or equals. That's pretty simple. Any of these, the shifts may be in there as well. Any of these multiplied by 10s have gone away. And when I say multiplied by 10, I mean multiplied by 16. Let's look at our loop. So we have a for loop. So this is basically the number, how long we're going to retry. It looks like checking the DMA status. So this may be before, like maybe a flag indicating whether DMA is happening already, and so we can't do the DMA until that's ready. So at A0, I'm going to call I, and we'll make this a for loop. It might be a loop with this check. This var v0 assignment is just an optimization. So it doesn't actually exist, and that will simplify this quite a bit. Because now this becomes, if this is true, go to. So to me, this seems like while this DMA flag is set and I does not equal what, like 32,000 something, 16,000, I don't know, whatever this hex number is. I plus plus and I'm gonna there could be a second check down here, or it could be something else. So I'm going to move the check down here. But that's probably wrong. Sometimes GCC's good at optimizing things like this, but I doubt it's going to do that. All right, and it looks like I have some issues here. There we go. Not better. I'm okay with that though. It could be a for loop. I haven't looked at the other like libcd code, so I'm not familiar enough with how it's written. It might be good to go look at the rest of that file and see. I don't really like the way that looks though, so I'm gonna leave that out. And we'll come back to it. We're doing some bit packing here. Not really happy with how this turned out in general. And there's a couple things here, like the load upper immediate 100 that's missing. We actually do have it. It's here of all places. And maybe this was a inner loop. I don't like this either. Which one is it yelling at me about? Line 33. I screwed something up all along the way. Yeah, unfortunately, I'm not making the progress that I was hoping. I'm going to go to Gamesters. And what I'm going to try to do is reuse the macros from the PlayStation Dev and see if that helps at all. It looks like so ARG 5 oh, some of this we should be able to clean up. So let's do that. Let's the mask isn't really a mask. Yep, I'm gonna start with his, or I'm gonna take over from his, and we'll see if we can get it any better. Thank you. So we don't have the DMA control type, and we're not going to use it. We're going to go back and use these other macros. And what's interesting is he came, so these must be documented somewhere with the appropriate names. Line 40, and so this was this macro. And this is quite a bit worse. So he probably was onto the right idea. So yeah, sometimes when there's other implementations, they're not necessarily trying to get source compatibility, and so you don't know what they're going for. So let's see where the problems are then in Gamesters. So the M2C version had this being done in a variable, and that may be what's happening. So we have the shift left up here, and I would expect GCC to pull this out, but it looks like it might not be. So I'm gonna add a variable for that. This is a unsigned 8, so we'll no help there. There is the check against 1 here. Oh, weird. Yeah, that changed it quite a bit. And there's a fake here. Which is probably adding some So there's a couple things here that probably don't make sense, but they're trying to force the compiler to do certain things, and occasionally we can get it to work that way, but it's probably not the way that it was originally written. So having this return value, which is a local variable, being set to volatile probably is not what we want. It looks like we're just returning this and have an int return. But we're putting the first value of the stack pointer on there, so maybe not. So again, like it's just odd. This is loading a word from memory and then to a local address that you've marked as volatile, or that has been marked as volatile. We're going to force this assignment. So it's kind of nonsensical. So there's some nonsensical things in here that I'd probably have to work through. And that's not what I wanted to do today anyway. I was just hoping that this would be a relatively straightforward one, but now we know it's sitting here for 4 months because it's not straightforward. So the local volatile doesn't make sense to me. This volatile pointer does make sense to me. Volatile indicates that regardless of whether the compiler thinks it should write that address or not, it should. Here, is it saying that it's a pointer to a volatile signed 32? I think so. Yeah, and there's a bunch of strangeness in here that is really just kind of forcing it. Like I said, I'd probably want to go review what the rest of this file looked like to see what the style of whoever was programming this was, and maybe you'd get a sense for how they wrote other things, in which case you could infer a little more about how this might be done. So kind of interesting here, like these addresses appear to be the DMA addresses as well. And so what it seems like this flag specifically looks like a completion flag. Thinking about this is very different too, because you're thinking about how Sony developers building an SDK, and by Sony developers, I mean, yeah, this probably was Sony. It probably wasn't SN Systems or Psygnosis, because this is pretty low-level hardware stuff. But anyway, we'll come back to that one day. What I wanted to do was pull in RBOO, and let's see if we can get that to work. So we're going to try to use decomp utils and see how that goes for us. This is something that Project Oblivion wrote. Kind of a rewrite of our make config script. I might come back through and run make config again to see if there's any symbols. So I wrote a tool for make config that gets symbols in a slightly different way than this tool does. And so we also want PSP EU version. And then we'll see if we can build it as is. Not sure what that error was about. Let's build and see what happens. I'm a little surprised that it's having to rebuild everything. Some file must have gotten touched along the way to cause everything to rebuild. I don't think This script updates the check file, so we'll have to update the check file, both of them. So we won't get a OK at the end for RBOO. Oh, we did. It does update the check file. Very good. Impressed. Oh, wow. It did both of them. Great. So I'm going to make a new RBOO branch. And we're going to start by adding looks like most of the config was added. Let's add we're going to be in boss. I'm going to type ST so many times, but we are in boss, so we're going to add RBOO, and let's see what's in here. We're going to focus on the unknown segments. So let's see what we got. So starting off, most of the overlay is what we'd expect. Create entity, breakable, etc. The things that we see in every stage overlay. We have possibly a single function file. Is that what's going on here? Okay. We'll look at the splat config in a second to see why this is pulled out by itself. Let's do that. Splat US SV RBOO is where we're looking. So yeah, that function shows up right at the end all by itself. It has RO data. Let's look at it. A medium-sized entity. It does have it looks like a few things that are going to be GTE macros, and so we'll have to go through and figure all of those out. I don't think I'm going to start there, though. Actually, the GTE macros probably are easier to debug on the PSP because they just show up as functions there. Let's look at this other unknown. So RBO 0, if you weren't here at the start, is Grant Richter, no, Grant Simon, and Sifa. Grant. Who else? Let me get to my wiki that has it all. Yeah, Ralph Grant and Sifa. So this is in the Reverse Coliseum, so we should actually see some overlap with that. Reverse Coliseum spelled with a C in reverse. So we have Boss Doors, Boss Torch, Owl Knight Sword. So we do have a couple things. When when the splits aren't obvious, it's not always clear where those are. And so we see here that there probably are additional splits here. So I'm going to want to do that sooner than later. And so where that RO data falls tells us which functions should be in a different file. So let's do that. So we want to look at the RO data file that contains those offsets. So I'm going to grep for those offsets. You can look at the splat config as well. Figure out where those are, and should probably have that open anyway. But it's part of this unknown, which is good. We may be able to see this in the PSP as well. If we have names for these functions, they might be showing up in a slightly different order. And that would help identify where these are. So 13634 is the first split, which is down here. So then we're going to take this jump table. We're going to see which function that is associated with. And it looks like this fellow here. Jump tables are only ever used in single functions. And it looks like this might be a little off because the Corral comment is used in this. So I think I'm going to disagree that this... no, I shouldn't disagree. It definitely is possible that this is in a different file, but it's not obvious to me because the alignment here was caused by the static string. So not going to worry about that at the moment. The next one also follows a static string. Not going to worry about that either. However, the static string is repeated, and if that static string existed in multiple functions, it wouldn't show up in RO data twice. It would be deduped. So those definitely are in different files, and we would not be able to decompile this with them in the same file. And my guess is that this is the same. And this is probably actually the boundary of... oh, this is just the other jump table. How many corrals do we have in here? We do have at least 3. I wonder if this is each of the characters. So maybe we should start with the first function and see if it's a driver for the whole boss fight. Let's see where these are used. Uh, 1400 lines is slightly larger file. Not terrible, but probably among the bigger ones. Let's try it. So we're gonna have to do some work here as well. I should find the memory addresses to turn on hitboxes. That'd be helpful. Then I'd have to get a save state in the Coliseum as well. It's quite a bit of data. And a relatively large outer switch. Definitely not going to finish this today. M2C could not figure out the type, so we're going to help it out. And it may be worth finding the PSP version early. Let's see if there's anybody else that uses the step or item string. It looks like not, so should be able to find that function pretty easily. It won't be, the RO data doesn't live in the assembly file on the PSP versions. Said it, and then I didn't follow my own warning. So we'll find out where this data is as well. So I've mentioned it before, but strings live in the data section of the PSP overlay, whereas they exist in the RO data section of the PlayStation overlay. And that's just a difference between how MetroWorks and GCC treat those, or treat that data. So let's look at the non-matchings directory. And so this is our equivalent PSP function. And we don't have the jump table. Oh, there might not be a jump table. Oh, that's interesting. Sometimes the MetroWorks doesn't create a jump table. And M2C couldn't figure this out either. An even worse signature than on the GCC one. At least GCC got a void star. This got a question mark star. Sorry, wrong one. All right, so I do want to get this compiling. There are a lot of compiler errors. This is a long function. Some of the benefits to it being a long function is that we should figure out a bunch of symbols which may end up helping us down the road with other functions. Let's get rid of all of those. A disadvantage is we have to work through a lot of data types for a lot of symbols. It's not as bad on the PlayStation. Let's figure out what some of these are. Some of them we might be able to tell by use what they are. So in this case, we're taking a reference to that address and then multiplying by 4. So this likely is a signed 32 or unsigned 32 array. So I'm going to put that data type, and it just possibly gives us a better starting point. Same thing here, it's multiplied by 4, so we know that the data is of a word size. It could be a 0.16 or some other struct, or even an array of 4 bytes. We don't know for sure. Unknown collision function, we should be able to get that. Looks like it's a signed 16 array. But as we find the data types for each of these, animate entity I think is an unsigned 8 array. What should happen is we'll pass those back into M2C, and then M2C should hopefully be able to fix up these additional data types for the local functions. And yeah, I really should go through and get a save state here, and we could turn on the debug entity boxes. And that'll tell us what the entity IDs for each of these are. So here we have a reference to var a, or that gets assigned to this var a0, and then that's passed to animate entity. So another unsigned 8 array. Same thing, a lot of animation. I'm going to get through these, and then I think I'm going to have to call it a day. I have some errands to run, and a limited amount of time to get them done. A lot of animation. Since we're dealing with 3 characters instead of the normal singular boss, there may be 2 other functions of about this size, maybe more. Or just assume that these were all unsigned 8 arrays. A little faster. Okay, so this one looks to me like it's going to be a signed 16 or unsigned 16, so something that's 2 bytes in size. I'm going to go with signed 16. I feel like in general, if it's unsigned, it'll be easier to identify than the other direction. So I'm going to take all of these, throw them into the context. I don't want to keep them in the context, but I do want M2C to be able to get to them to run a new decompilation. So hopefully several of the variables get defined, and they did. Still screen? Or is that from earlier? I know I screwed up my screen earlier. I'm not sure why var a0 was hard for M2C. Step should be assigned 16. And then now there's several offsets, different places that couldn't be figured out. So we have some entity that's behind us, so 1 entity less. So do we have an entity pointer? We do, but I don't like any of those. So I'm going to make a new one. Not call it self. And that's going to equal self minus 1. Based on this being set to scroll y I high, I'm going to assume that this is pause y I high and not look up the offset or do the math for the offset. That could be a terrible mistake, but I'm pretty confident. Same here. Every time I see these, I'm going to do a self minus 1. It's possible that the self minus 1 happened somewhere up above, and we could actually look up here. There should be a minus BC somewhere. So that's happening in case 0. It's happening in case 2. So it looks like this is a fall through, so I don't need to do it again here. No, it is done again in case 2. Are these looking the same? I think so. Initialize, create, set step. Initialize, create, set step. I think so. I think that's fine. This one I will have to look up. I am slightly worried that that is in the entity extension space. Where's my calculator? It is. It's about 16 bytes into the entity extension space, so it's entity ext, and we're going to go with illegal for now. We'll say, we'll pretend it's a Boolean and just say that it's offset 16. I don't know if that's the case or not. And then we're going to do the same thing down here. And whether or not this is being set up twice, I don't know. Unknown 50 on line 295. This likely is one of those situations where it's two 16-bit values being loaded at the same time as a word. We're looking for offset 50, so yeah, pose and post timer are both being loaded at the same time. And so then we have to figure out, and I always, I'm going to go with pose 5 and pose timer 0. Yeah, it could be the unsigned 16.4. I agree. So there's going to be a couple of these. We'll just have to probably update the pose value. So another one on 348, it looks like. Search for unknown 50s. This one is pose 3. Pose 11. It's possible that the order of the condition is wrong. I don't think that's going to affect the... Oh, shoot. I don't think that's going to affect the PlayStation. I wasn't aware of what I was copy pasting. Okay, just a few more. So This is assumed to be a sine 32. But it looks like a 0.16. So, like I said, it seemed like it was... Oh, maybe not. They're both coming off as sine 8s. So what is a 4... Do we have a rect? That's short. A vector. They're like a vec 8. Those are long, shorts, C vector. Let's try C vector. B8. My brain is not working. 6B8. So temp_v1 underscore 10 is going to be the C vector pointer. And here we can do X and Y. And Y. +1 is weird. So I think that would make this Z and this would be CD. So that makes it a quad. This doesn't make sense anymore. And I guess there's CV, CY. No, what is the C vector? Just give me normal names. RGB, of course. Okay, so we got this compiling. We're at about 50%, and I don't even want to look at what it looks like right now on the PSP. That's all I'm going to do today. We'll try to get a little further tomorrow, maybe get it done tomorrow. But we're working on the Grant, Ralph, and Sifa boss fight, RBOO, in the reverse catacombs. No, the reverse Coliseum. Why did I say catacombs? Reverse Coliseum. And this is Decompiling Castlevania Symphony of the Night. We'll be back tomorrow. Adios.